Alright, so properties of numbers is the next topic that we're going to be covering. A lot of these you have seen before, but there may be some that are newer or just haven't seen very often in the past. So properties of numbers, starting off with the definition, are statements that are true for any numbers. And what they do is they justify the steps when we are simplifying expressions and solving equations. So we can't just do any step we want to for no apparent reason. There has to be a reason why we do each thing that we do when we simplify expressions or when we solve equations or whatever the case may be. And so properties give us the ability to take those steps that we need to take to simplify. So one of the properties that we're going to talk about today is the associative property. Associative property applies to both addition and multiplication. So a couple different examples. So if you have a number added to another number and it's grouped plus a third value, what the associative property says is that the order or the grouping that you put them in is not important. So see that the order is the same here. It's A, B, C, A, B, C. But in the first one I've grouped A and B, and the second one I've grouped B and C. So if you do that with numbers, here's an example, that it doesn't matter whether I group the first two numbers or the last two numbers. If all of them are addition, I'm going to come out with the same solution or simplification. So same thing happens with multiplication. If I have D and E being multiplied together and then being multiplied by F, it doesn't matter which two are done first in the grouping. But notice that the order is still the same. It's the grouping that's different. So if we did that with numbers, 4 times 2, and then all that multiplied by 3, same thing over here. The order is still not the same. I'm just switching out the value. So or switching out the grouping, whether I group the first two or the last two values. So associative property says grouping of values does not matter when we're adding or multiplying values. And notice that the order, and I'm capitalizing this because it's important, has not changed, only the grouping. So I like to remember associative as associating with people and grouping them. So you group your group of people that you associate with. Maybe that can help you kind of put those two together. Then we have commutative property, also of addition and multiplication. And this one, it talks about the order. But the order that we put addition in doesn't matter. I can do 5 plus 7, and it's going to be the same as 7 plus 5. It doesn't matter which order I put it in. Same with multiplication. I can do 3 times 4, or I can do 4 times 3, and it's going to give me the same value. So the order of the values does not matter when we're adding or multiplying. We know that when we subtract or divide, it definitely matters what order we put them in. But in the case of addition and multiplication, we can swap those, and it's okay. Alright, then we have distributive property. So distributive property is when I have a value outside of a group and I'm going to apply that value or distribute it to all things inside that group. So for example, I have this A and I have B and C being added. I'm going to multiply A times B and A times C. So if we did that in terms of numbers and variables, let's say we have x minus 3 inside the group and I got to multiply 2 by both of those things. Then I'm going to be doing 2 times x, which is 2x, and 2 times negative 3, which is negative 6. That's distributive property. I'm just distributing that value on the outside of the group to everything inside the group. So if multiplying a value by a grouped expression, okay, and it's not always parentheses, but I want you to think of it as parentheses. Sometimes it could be a different grouping symbol. But when we're multiplying a value by a grouped expression, you have to multiply the value by each individual term in the expression. That's really important because I'm not just multiplying the 2 by the x. This grouping is telling me that the 2 has to be multiplied by both terms. Okay, then we look down at identity property. So identity property is also addition and multiplication. So it just says that if I want to keep the identity of what I've been given, add 0 to it. Anything plus 0 is going to keep its original identity. 12 plus 0 is still 12. A plus 0 is still A. Even if I don't know what A is, it's still A. So anything plus 0 is still itself. And with multiplication, it's similar, but we use 1. Anything that we multiply by 1 keeps its original identity. So B times 1 is B. But 27 times 1 is also just 27. It keeps its original identity. So the value of a number stays the same if it's added to 0 or if it's multiplied by 1. And it doesn't matter. You want to keep your original identity. Multiplication, that's by 1. Addition, it's by 0, or addition to 0. Right, then we have the inverse property, also addition and multiplication. So in this case, we have A plus negative A is equal to 0. So a number plus its opposite is 0. So 5 plus negative 5 gives us 0. Okay, that's the inverse property for addition. For multiplication, we use the inverse being a reciprocal, or the flip. So B times 1 over B gives us 1, and 7 times 1 over 7 gives us 1. And so notice that what we're trying to get to with the inverse is different as well. If I'm wanting to, we're going to cancel out, even though it's not technical terms, but if I'm wanting to cancel out an A, I want to get 0. I want it to go away completely. And so if I want 5 to go away completely, I have to add it to negative 5. Okay, that's finding the inverse. Same thing here. If I want B to cancel out, I have to multiply it by the reciprocal, or 1 over B. And that's going to give me 1. So I don't want it to completely go away. I want it to become 1. So that is important. That inverse property for addition, we're looking for 0. But if we're doing it for multiplication, we're looking for the value of 1. So when you add a value to its opposite, or its inverse, the value becomes 0. And when you multiply a value by its opposite, its inverse, or we call it a reciprocal, the value becomes 1. Okay, so that's super important when we talk about inverse property. We use this a lot when we are solving equations, because we want to use the inverse to undo something. So this is important to know. Now with reflexive property, this one is really nice, super easy. A value always equals itself. So A is equal to A. 14 is equal to 14. 3x is equal to 3x. Whatever you want to put in that place, it's equal to itself.